I'm recording this so you guys can have so you could go back and take a look at it. Now let's take a look at number one, or the first one. Now, if you would have pulled out the worksheet that I gave you, or the note sheet on the fundamental theorem of calculus, if you go down to the bottom, it's part 2. I even told you it's the second fundamental theorem of calculus. It talks about integrating, or when you're taking, basically what's happening here is you have the derivative of the integral, because we know f of x is the integral, but we want f prime, so we need to take the derivative of an integral. Now, what do we know about derivatives and integrals? If you take the derivative of an integral, what happens? That's 0. They cancel each other out. But when we have this crazy limit of an x up top, what do we do with that x? We just plug it in where t is. So this just becomes x squared minus 2x. That's your answer. No, you're not integrating though. You're differentiating. It's like adding and subtracting. It's like you added something. The integration is adding. The differentiation is subtracting, and you get back to what the original function actually was. The original function, which is what we're looking for, that f prime, that integrand. The f prime, it kind of comes from this idea. F of x is equal to the integral of, from a to x, of that t squared minus 2t dt, where this is f prime of x. So that whole integrand is f prime of x, but it's written in t's. So when we actually take the derivative of this, the derivative cancels out the integral, but then we have to replace it with the x's on there. Now, there would have been one case if it was something like from 2 to x squared. We would replace it with x squared, and then have to multiply by chain rule, because it doesn't work. You'd have to multiply by a chain rule on there. We're gonna shore up that knowledge a little bit later on, but this was something that I introduced about I'd say a week before the break, and I was seeing if anyone actually remembered it. And from some of the comments that I heard, it didn't really happen that way. But this problem is an easy problem. Don't make it harder than it is. And you'll get a problem like this where you have to take the derivative of an integral, and it's just a replacement and you're gone. It's a drive-by calculus problem. Now, well, you just drive by it and do it and get it done with. Now this one, you can separate it. And what is an integral actually calculating? Yep. Area under the curve. Now, we can actually integrate this one without a problem. What's the integral of 3? 3x. And we're going to evaluate that from 1 to 4. So we're kind of taking care of this part. So it'd be 3 times 4 minus 3 times 1. 12 minus 3, which is what? 9. Now, we run into the problem with the absolute value. The absolute value, a good way to actually do this is to graph it out. Because I can take care of the 3 really fast. Because they're two, I mean, whenever you're adding or subtracting two different things, you can split the integral and say it's the integral of this one minus the integral of this one. So it allows us to do like x squared plus 3x plus 4 and integrate each term individually and add them together. Now, if we were to graph this at 0, well, we just care from 1 to 4. So at 1, what's 1 minus 3? Well, we got the absolute value of x minus 3. If you don't know how to graph this right off the bat, then just plug in numbers. And at 1, 1 minus 3 is a negative 2. So what's the absolute value of negative 2? 2. At 2, it's 2 minus 3, which is a negative 1. Absolute value of negative 1 is 1. 3 minus 3 is 0, so I got a 0 there. And at 4, it's at 1. So this is the part that I'm actually trying to calculate. What's this length right here? That's a 2. This length right here is 2. So I can figure out the area of that triangle is 1/2 2 times 2, which is 2. Now what's this length from 3 to 4? 1. What's this length from 0 to 1? 1. So the area of this guy is 1/2 times 1 times 1, which is 1/2. Add them together, 2 plus 1/2 is 2.5. So now if I looked at this and said, alright, I already figured out this integral, which was 9, from right here. Now, what's the total area under the absolute value curve from 1 to 4? What did we figure out it was? 2.5. So I have to subtract off 2.5. Answer 6.5. So if you want to, you can play around with making part of the absolute value negative, or the opposite of x minus 3, or the x minus 3, depending on if it's going to be positive or negative, whatever. Or you can graph this. I recommend graphing because it's usually faster and it's easier. And then you're just calculating areas of triangles and then adding those up together. It's good to go. Now this last one, we haven't done the mean value theorem yet, but I wanted to kind of throw it at you and say, all right, we've done a mean value for functions. What's the average value over a time? And now what we're doing is there's another way that we can actually calculate average value. And in this case, it's the volume of air, of R. I guess I was in pirate mode. Air in the lungs during a 5-second cycle, and it's approximated by this model right here. Now the mean value theorem is basically taking, just kind of go with the formula for this. So the formula is going to be 1 over 5 minus 0 times the integral from 0 to 5 of v of t dt. Now I'm going to show you how to do this on the calculator, because this one is a calculator problem if there ever was one. So alright, so now we want to build this up. It's 1 over 5 minus 0. What's 5 minus 0? 5. So I want 1 divided by 5, and I put that in parentheses, times, now I need an integral. So I want to, and I'm going to figure out a numeric integral, so I'm going to go Menu, Calculus, Numerical Integral. And now I have everything I need. Bottom is 0, the top is 5, and now I got to plug in everything. 0.1 729, and then we're going to get x cubed. Oh, nope, it's x. Sorry, I was working backwards. And so it's plus 0.1522 x squared minus 0.0374 x cubed. And now I have to make that dx. There's your answer. So in this case, if you are going to get some crazy integral like this, there's two things that the AP Calculus test will tell you. It'll say set up but don't solve. This is one of those because you need a calculator or else you'll spend probably a good 10 minutes working on it because you have to multiply. You have to cube and square, and there's a lot of stuff. There's a lot of work to get this one done. And a lot of busy work, which the AP, believe it or not, the AP Calculus test is not about busy work. It's about getting stuff, it's about the calculus. So this one would be either set up and don't solve or use a calculator. It would be a calculator problem. But when it's asking for the average amount of air in your lungs over this time period, you can actually do that if you know the function for the volume of the air. It's going to be the integral of that, which is the entire shape, which is the area under the curve for the volume function, divided by that b minus a, and that's just basically going to give you an average value. So it tells you what value it is at every single point, and then it tells you divide. It's calculating an average. If you think of what an average is you add up every number and then divide by the total numbers. Well, in calculus, averages are calculated by integrating from, in this case, 0 to 5, because it's adding up everything that's happening from 0 to 5, and then you divide by 5. And once you're able to do that, you get your average. So it's calculating average exactly the way that we've always calculated average, but what it's doing is it's adding those really, really tiny lines to make up the area under the curve. And so it adds up an infinite number of lines and then divides by the interval that you're looking at. So it's just a different way of approaching an average in calculating an average, which usually means add up everything and divide by the number of stuff that you added. Well, the stuff that we added only went from 0 to 5. So we're going to divide by 5. And so that's the case for that.